Hi, everybody. I'm Justin Bohn. I'm from J&J. I'm here to talk about something that we presented at the symposium titled Development of an Automated Comparator Ranking Algorithm for the Reward Initiative. So reward is a framework that seeks to identify unknown benefits of existing drugs by generating effect estimates between all drugs and all condition outcomes. It relies on the self-controlled cohort design to generate effect estimates. And this design is very efficient, but it's susceptible to temporal biases, in particular protopathic bias. And so it may not be the only approach that we could use. In contrast, the new user comparative cohort design is an alternative approach that's well accepted in pharmacoepidemiology. But in terms of scaling that to all by all for reward, we have the problem of comparator selection. We need to find a comparator for every target cohort we wish to analyze that's appropriate. And so what we tried to do here was to generate comparator recommendations based on covariate similarity for all target drug cohorts that we use in reward. And I'll tell you a bit about how we did that next. I have to find the arrow keys are not working. There we go. Okay. So we generated cohorts for every RX norm ingredient in 5 data sources that we use in reward and extracted aggregated covariate data across 5 domains. Those are depicted at right with the time windows in which we extracted the covariates, et cetera. I'll go over those more later when we look at the app. Once we have those aggregated data extracted, we formed all possible pairs of cohorts, then computed the cosine similarity between the members of each pair separately by each of these 5 covariate domains. And then we average those to get the main similarity metric, which we can use to develop the ranked list of comparators for a given target drug cohort. We demonstrate these results in the poster using IBM CCAE data, and in the app that I'm going to show you, also CCAE data. We have 4 other data sources that will be in the paper, but we will go over the app in a bit. And just to give you an overview of what we think we found here, in the poster, we had 6 example drugs from different therapeutic areas, and we found that the top ranked comparators for those drugs corresponded very well with subject matter knowledge. Everything that came up was an alternative treatment to the indication of that target cohort. And so we think that this tool can be useful to you as investigators who may want to do a comparative cohort analysis but not know of a good comparator for your target drug of interest, or maybe you're looking for a null comparator to emulate a user versus non-user comparison. So this could give you some information to help you make that decision. And so I'm going to go over the app now, but before I go, I'd just say that, I hope you use this tool. And if you do, don't forget that once you select a comparator, your job's not done. You have to do plenty more in terms of finding a unconfounded estimate. But with that warning, I will switch to Chrome and show you the app. So this is the Comparator Selection Explorer Shiny app. It's available at data.odyssey.org. And you can see that at the left, there's a panel for settings where you can select a target cohort of interest. In this case, ocrelizumab, a multiple sclerosis drug, is pre-selected, but you can pick anything you want from the list of RX norm cohorts. And indeed, we've actually done this also for ATC level 3 class-based cohorts of new users. So all these new user cohorts can be selected as a target, and you can select what type of comparators you want to look at. You then get a comparator listing table at right that is ranked by the average similarity score across the 5 covariate domains. And in this case, they're listed out here, and you can see that these are all drugs for multiple sclerosis. So we did a good job here at finding drugs that we would assume to be similar just based on subject matter knowledge. You can also scroll to the right and see all the domain-specific similarity scores, as well as some information about relationships in the ATC hierarchy. So for example, if I wanted to find a top comparator that is related to ATC level 4, I can do that here. So I'm going to enter a 1 in here, and now we're only looking at those that are related at ATC level 4. The top one is teriflunomide, a common other multiple sclerosis drug. So I'll pick that in a second, but I would also note that if you wished, you could rank this table based on any of these columns. Perhaps you want to find a comparator that has the best similarity in terms of demographics alone, or only in terms of medical history, et cetera. You could do that. I'm going to use the average here and select teriflunomide. as an in-class comparator. And that will produce a bunch of tables and figures below here. First, I'll orient you to this overall diagram. I'm sorry for all the scrolling, which depicts the overall similarity score on the y-axis versus the comparator rank itself on the x-axis. Shows you a bit about how similarity changes by domain and over the range of the ranks. And so, for example, the red is the presentation domain, which tends to fall off very precipitously here. Going down to what's produced when I clicked on teriflunomide as a comparator, we have sort of a table one style table separately by each domain. So the demographics are given here in terms of age and sex. You can see the prevalences in the ocrelizumab and teriflunomide cohorts, as well as standardized differences. The same is shown for presentation below. So, for example, the top most different covariate here, because this table is by default ranked by the absolute value of standardized difference, is multiple sclerosis, which is almost entirely present in the ocrelizumab cohort and only present about half the time in the teriflunomide cohort in this time period. You could also search this table. So if you wish to find a specific covariate, say depression, I'll type depression in here, and you can identify which covariates are related to depression, their prevalences, and their standardized differences across the target and comparator cohorts. You also have some visualizations. So I'll go back up here. We have a diagnostic plot at left that's a scatter plot showing you the prevalence in the target cohort on the x-axis and the comparator cohort on the y-axis. And so obviously the degree to which those dots align on the horizontal is the degree to which these cohorts are similar in their covariate prevalence. The same information is also given in terms of standardized differences, which is a more traditional pharmacoepidemiologic measure of covariate similarity. There's some dotted lines there to indicate the sort of traditional bounds of imbalance covariates of -0.1 and 0.1. And you can see that most of these look like they're within that range, although not all of them, and there's quite a bit of overplotting. So there's also tables for all the other covariate domains, for instance, medical history, which is one covariate extracted per every SNOMED condition observed more than 30 days prior to the index date. And you can see those, again, ranked by the absolute standardized difference. So the most divergent of those is the fatigue variable, much more common in the ocrelizumab new users than the teriflunomide new users. There's also prior medications. So that's one covariate extracted per Rx norm ingredient observed more than 30 days prior to the index date. Again, this is ranked based on absolute standardized difference, and the biggest difference there is just the prevalence of the comparator cohort, which obviously doesn't occur in the teriflunomide cohort as their new users, but does a bit in the ocrelizumab cohort. And finally, we have visit context, which is just one variable for emergency room visits and one for inpatient visits. And so all of these tables are sortable and searchable. So for instance, if you wish to find the most common prior medications in the ocrelizumab cohort, you could sort on that, and you'll find that it's methylprednisolone. And you could do the same for the comparator cohort, or you could find those that are the most similar in terms of standardized difference using this column, et cetera. So we hope that you will take a look at this app, see if it can be of use to you, and that you'll reach out with any questions or comments you might have. So thanks very much.